I'm back, guys. So let's discuss meet in the middle algorithm. So let's try to understand this with the help of a question. So the question is very simple. You are given an array of integers. You have to determine the maximum sum subset having sum less than or equal to x. You have to only print the sum and not the subset itself. So let's look at the input constraints. The input constraints are that size of array is less than equal to 40. Element of array will be greater than equal to 1, less than equal to 10 raised to power 12. S will be greater than equal to 1, less than equal to 10 raised to power 18. In case you didn't understand the question, so let's try to basically understand this Delvo test case. So test case 1 is you're given input array 1, 3, 10 and S is 12. So the output for this would be 11. Why output is 11? So like let's try to generate all the subsets of this array. So there are like 3 elements. So total possible subsets are 2 raised to power 3, that is 8. So here are all the possible 8 subsets. And corresponding to each subset, I have written the sum of the elements in that particular subset. So we are required maximum sum subset having sum less than equal to S. So maximum sum less than equal to S here is 11. So hence the answer is 11. So we have to only print this sum, not the subset. That is 1, 10. Don't have to print the subset. Okay. Test case 2 is array is 3, 4, 12, 5, 2. S is 10. Output will also be 10 because the subset containing elements 3, 5, and 2 would be the answer. So remember this test case 2. So we are going to use this to understand the meet in the middle algorithm. So yeah, let's first talk about the brute force solution. So the brute force solution is very simple. You generate all the possible subsets for the given array, and among all those generated subsets, you try to find the maximum sum subset having sum less than or equal to x. Okay. Now, like the time complexity for that would be order of 2 raised to power n, that is exponential. And since the maximum value of n is 40, hence this cannot pass the time limit. Okay. So let's try to optimize this. Let's try to understand the meet in the middle algorithm. And one important observation to make here is that let's say if the size of the n, like the maximum size of value of n which was allowed was 20. Okay, so in that case, this brute force solution will pass because in the worst case we'll generate 2 raised to power 20 possible subsets, and like 2 raised to power 20 can easily pass the time limit because it is what around 1 million. 2 raised to power 20 is around 1 million. So this is the idea of the meet in the middle algorithm as well, that it tries to decrease the input size. How does it do that? Let's look at that. So the basic idea of meet in the middle algorithm is that you split the large set into two small sets of approximately equal size. Why I'm saying approximately equal size? Because in case the array has like odd number of elements, so you cannot divide it into two small sets of equal size. Second step is that you do some processing on those small sets. The processing depends on the question, and eventually combine the answer to from the two small sets to find the required solution. So this is like somewhat similar to recursion, but in recursion what we do is that we keep on dividing the given input until we reach a terminal condition. But in meet in the middle algorithm, we only do that once, and we always try to divide it into uh, sets of approximately equal size. Okay. I mean, in the worst case, size can differ by only one where the elements are odd, like number of elements are odd. So let's try to basically apply this idea in the given question. So we are going to look at the test case 2, which was array was 3, 4, 12, 5, 2. So I have divided into two smaller arrays of nearly equal size. So first array has first three elements 3, 4, 12, and second array has last two elements 5, 2. Now we generate all the possible subsets for array 1 and we generate all the possible subsets of array 2. Okay, so here I have written all the possible subsets of array 1. Here I have written all the possible subsets of array 2. Corresponding to each subset, I have written the sum of the elements in that subset. Okay, like for this subset containing elements 3, 12, the sum is 15. Now, how can we exploit this idea to get the solution? Basically, how does these subsets of these two arrays, array 1 and array 2, are going to help us? So if you look at very closely, I mean, if another important observation here is that you can actually generate all the possible subsets of the original array by using the subsets of these array 1 and array 2. How? For each subset of array 1, okay, if you do the union with each subset of array 2, you will get all the possible subsets for the given array. In case you did not understand this question, I will like tell you to try to do it using pen and paper, and you can see like if you can for like take each subset of array 1 by one and do the union with all the subsets of array 2. And like mathematically as well, like array 1 and array 2 are approximately equal size. So let's say when they have, if the array has even number of elements, so the size of array 1 will be n by 2, size of array 2 will be n by 2. Possible subsets for each are 2 raised to power n by 2. And we are doing like for each subset of array 1, we are doing union with every subset of array 2. So like 2 raised to power n by 2 multiplied by 2 raised to power n by 2 is 2 raised to power n, which are also the number of like subsets possible for the original array. So how does this observation help us? So we are supposed to find the maximum sum subset having sum less than equal to s. Okay, and I told you that using the subsets of array 1 and array 2, we can generate all the possible subsets of the original array. So this means that there exists one subset in array 1 and one subset in array 2. If you will take these two subsets and do a union of them, you will actually get the subset which will have the maximum sum which will be less than equal to s. Okay, I mean for this particular case, that subset in array 1 is 3 and the corresponding subset in array 2 is 5 comma 2. If you will do the union of these two, like 3 comma, you will get the subset 3 comma 5 comma 2. And this is the subset of the original array. And the sum of the elements in this subset are 3 plus 5 plus 2, that is 10, which was the answer as well. Okay, so your problem is now reduced to finding that one subset in array 1 and that one subset in array 2, which when union together will give you the sum, maximum sum less than equal to s. Okay, how do we do that? It's very simple. We will store all the elements of array, basically the sum of the subsets of array 1 in one of the array, and in the second array we'll store the sum of all the subsets of array 2. Okay, and we will sort those two arrays. So here I have done that particular step. I've taken this sorted sum array 1 which contains these sums, okay, and they are sorted. Here you can see that, and similarly for array 2. Now the third step is that we need to find one of the sum in this, one of the sum in this and one sum in this array, sorted sum array 2, which when combined will give us the required answer, that is maximum sum less than equal to s. Now there are various ways to find it. This is a very standard question. You can either use binary search or you can use two-pointer approach as well. So here I've used two-pointer approach, so I'm going to explain you how. So I've taken low as 0 and high I've taken as basically it is pointing to the last element of sorted sum array 2. Okay, so low is basically pointing to the first element of array 1 and high is pointing to the last element of sorted sum array 2. Okay, I'm going to use array 1 array 2 instead of these two long names. Okay, these two long names I have kept so that you can basically to make the code verbose so that it is easy for you to understand. Now yeah, so this comment is actually wrong. Yeah, anyways, so this max sum is actually going to store the answer for us. So maximum I have initialized as minus infinity. So I iterate until till low is less than the array 1 size and high is basically greater than equal to 0. So for array 1 I am traversing to the right like this way, left to right, and from array 2 I am traversing from right to left. Yeah. So I find the sum. Okay. How I find the sum is that whatever the numbers are present at low and high index in array 1 and array 2, I add them. Now, if that particular sum is less than s, so this might be our answer. So hence, what I am doing is that I am basically checking. I am doing this basically. I am storing the maximum of max sum and the sum which we have received in this max sum, and then I am incrementing the low pointer. Why I am incrementing the low pointer is because like I have got a sum which is less than s. Okay, so I have to, my target is to find the maximum sum less than equal to s. So hence I should basically increase the sum, try to increase the sum, and I can increase the sum by incrementing the low pointer by going to the right hand side in the sorted sum array, because that's where all the great big numbers are. Now else if sum was greater than s, so definitely this cannot be the answer. So I am decrementing my high pointer because I want to find the maximum sum less than equal to s. So I have got the sum which is greater than s. This means that I have to decrement this sum. For decrementing this sum, I'm going in the left, basically one step left in the sorted sum array 2. And that is because all these smaller numbers are in the left side of the array 2. And the third condition, else, basically if we have received the sum which is exactly equal to s, so this means we have got the answer. Now there cannot exist any greater sum which will be less than equal to s. So here we are directly returning to save the cost of basically doing the while loop. Eventually when this while loop will be finished, so there will be two possibilities. Either you found the answer or you didn't find the answer. Okay. So this is what I am doing. I'm checking if the maximum sum values was unchanged. Basically if it is equal to minus infinity, we had initialized it to minus infinity. So this means that answer does not exist. So I am throwing an exception. You can do whatever you want based on the question. If it requires you to return some terminal value or throw an exception. But yeah, this is what it is representing. That answer did not, basically answer was not there. Else you return the answer, that is the maximum sum. So this is all about the meet in the middle algorithm. Okay, like if you'll see, meet in the middle algorithm is nothing. I mean, how did we solve this question? We basically used sorting and binary search, sorry, two pointer. I mean, you could have used binary search as well. But yeah, the meet in the middle algorithm step was this only, that divide the input into two small inputs of nearly equal size. Okay. And one important thing to note here is that the time complexity for this would be what? Order of 2 raised to power n by 2, right? And it will have some amounts as well. I mean, let's try to actually compute the time complexity as well. So this step will be what? On, okay, and this step would be what? This step would be order of 2 raised to power n by 2. Basically, this would be n by 2 plus 1, because we are like 2 raised to power n by 2 for this and 2 raised to power n by 2 for this. So when you will add this, so you will get order of 2 raised to power n by 2 plus 1. Okay, so this step was that. Now here we are storing these in this in an array, these two numbers, and sorting them. So again, the time complexity for this would be what? Order of, like sorting is n log n. So n here is what? 2 raised to power n by 2. So it would be 2 raised to power n by 2 log of 2 raised to power n by 2. Okay. So I am representing 2 raised to power n by 2 by some, let's say x. So it would be x log x. Here x is what? 2 raised to power n by 2. Okay. And this step where we are doing two pointer, it's like a linear step. So again, this is order x. So to get the eventual time complexity, you have to add all this. So your time complexity would be something like this: order of 2 raised to power n by 2 plus 1 plus order of 2 raised to power n by 2 log 2 raised to power n by 2 and plus order of 2 raised to power n by 2. So eventually, like the bigger term here is this only, order of 2 raised to power n by 2 log 2 raised to power n by 2. So that is your time complexity. So eventual time complexity is this order of, like, again, I can write x log x, where x is this. I'm writing this to make it a bit clear, like the time complexity. So this is your time complexity. So maximum value of n is 40. So n by 2 would be, like, maximum value of n by 2 would be 20. And this you can see can very easily pass the time limit. So yeah, I think that was it. So for meet in the middle algorithm, the biggest hint is that if you can apply meet in the middle algorithm in any question or not, is that if 2 raised to power n cannot pass, but 2 raised to power n by 2 can pass. Okay. So this is the most important for meet in the middle algorithm, that the input size should be small, and small in the sense that 2 raised to power n by 2 should be able to pass. Okay. So, I mean, apart from this, we did not do anything related to meet in the middle algorithm in this particular case. So we did sorting, we did two pointer, but the only step for meet in the middle algorithm was that dividing the array into two small arrays of nearly equal size. So I mean, this algorithm very simple. It just has a fancy name. So anyways, thank you guys for watching. Please don't forget to like, subscribe, and comment on this video, and I'll see you all next time.